Hello, pre-calculus students. We have here a problem that has to do with derivatives, slope of tangent lines, and instantaneous rate of change. And so I have a function here, f of x equals 3 over x minus 1, and we're asked to do three things. First is to find the derivative, f prime of x. Next is to find the slope of f of x at x equals negative 2, and then finally find the equation for the tangent line at x equals negative 2. So I'm going to start with part A here. I'm going to say that f of x, f prime of x rather, is equal to the limit, and this is just the definition of the derivative, as h approaches 0, of f of x plus h minus f of x, all of it divided by h. Okay? And just to kind of recap or review a little bit, this h here represents the distance between x plus h and x. In other words, if you have a point, let's say you have a curve like this, and we want to find the derivative at this point, we'll call this point here x, or rather, this point here, we can call this x, and if we want to find the derivative at that point, we pick some other point here, and the horizontal distance here is h, and we basically want to find the slope as these 2 points get closer and closer together. In other words, as h gets closer and closer to 0. Okay, so that's what this h really means. Okay, so I'm going to erase that and just give myself a little bit more space to continue here. So in my next step, remember to write the definition of limit, or write the limit every single time. F of x plus h, so I'm going to take this function, and wherever I see x, I'm going to substitute x plus h in there. Okay. So this is going to be 3 over, and again, instead of x, it's going to be x plus h. I'm going to write the parentheses in there, minus 1, minus f of x, which is 3 over x minus 1, and then everything over h. Okay? So all I've done here is taken the definition of the derivative and then applied it to this particular function. And now we have kind of a confusing, or at least it looks very messy, type of scenario where you have a complex fraction. That's where you have a fraction here, and you have another fraction within that. So I think the best way to handle this is just to pull out this denominator, and instead of saying divided by h, we're going to say times h plus 1. So it's going to be 3 over x plus h minus 1 minus 3 over x minus 1, and then everything multiplied by 1 over h. Okay? So instead of saying divided by h, we're going to multiply everything by 1 over h. And now what I can do is just work with the expression here inside the parentheses, try to get them to be the same denominator so I can get things to be simpler. Now, the reason that I'm doing that is because I cannot substitute 0 in for h. We can't do direct substitution because we're going to get 1 divided by 0, which is undefined. Okay. So it's going to be the limit as h approaches 0, and I'm going to take this part right here and just work with that a little bit. This part right here. We can get a new marker here that actually works. So this part right here. Okay. So it's going to be 3 over x plus h minus 1. Multiply the top and bottom by this other denominator, so I get the lowest common denominator, so x minus 1 over x minus 1 minus 3 over x minus 1 times the other denominator here, times x plus h minus 1 over x plus h minus 1, and then again everything times 1 over h. I'm going to select this up so you can see a little bit better. So this is equal to the limit as h approaches 0, and I'm going to combine this multiplication of fractions together. So 3 times x minus 1 minus 3 times x plus h minus 1, all of it over x plus h minus 1, that's this part, times x minus 1. Okay. All of this, once again, in parentheses, times 1 over h. Okay. Now I'm going to erase some of this stuff and bring it back up to the top here. Or better yet, I'll get a new board and continue from there. So we'll continue now just by, distributing everything over here and seeing what happens from there. So it's going to be the limit as h approaches 0 of 3x minus 3 minus 3x minus 3h plus 3, all of it over x plus h minus 1 times x minus 1, all of this times 1 over h. And you can see now that on the numerator, some of these terms are going to cancel and make our problem significantly simpler. So we can see that there's a positive 3x and a negative 3x, so those are going to cancel. You see that there's a positive 3 and a negative 3, so those are going to cancel. And all that's left here is negative 3h. So this is the limit as h approaches 0 of negative 3h, all of it over x plus h minus 1, x minus 1 times 1 over h. And the h on the numerator and the denominator is going to cancel. And so this leaves me with the limit as h approaches 0 of 1 over x plus h minus 1 times x minus 1. And now that I'm able to remove the h variable from the denominator, I can substitute in 0 directly and get my answer from there. Now, if you notice here, there's another h in the denominator here, but that's okay because this one is not going to lead us to division by 0. It's got sort of other stuff around it. So let me continue here. We can just do direct substitution so that all that is equal to 1 over x plus 0 minus 1 times x minus 1. And that, of course, gives us 1 over x minus 1 times x minus 1, or 1 over x minus 1 squared. Oops. And I notice here that I just made a mistake because I canceled out the h's, but this here I still have a negative 3 up there. So let me correct my mistake right now. Because it should not be a 1, it should be a negative 3 up here. So there should be these 1s here should really be negative 3 that are up there. Okay, and this is just a mistake on my part of writing the wrong thing. So it should be negative 3 over x minus 1 quantity squared. And I'll write that in the final answer. F prime of x equals negative 3 over x minus 1 quantity squared. So now this leads us to our second question. Our second part of the question here is that find the slope of f of x at x equals negative 2. And one of the nice things about this is that the derivative is the slope or at a particular point. Okay? So if I want to find the slope at x equals negative 2, all I really need to do is substitute negative 2 into f prime. This will give me negative 3 over negative 2 minus 1 quantity squared, and that is going to come out to be negative 1/3. Okay. And finally, in the last part, we're asked find the equation for the tangent line at x equals negative 2. Now, one thing that I do know about this, and I'm going to erase some of this stuff up here. Okay. So I want to find equation, pull this down here, equation of tangent line at x equals -2. So let's say I had some sort of graph like this that looks like that, and at -2, this is going to be the line, and I need to find the equation of this line. But I already know from using the derivative in part B that the slope is going to be -1/3. So I know that m is going to be equal to -1/3. Now all I really need to know is find a point. If I have a slope and a point, then I can of course write the equation of a line. So to find a point, this point right here, and I'm sorry, this equation is f of x, all I really need to do is find f of -2, because if I use that, that's going to give me the coordinates for this point, or the y coordinates rather. I already know the x coordinate is going to be -2. So f prime, or really just f, I'm sorry, not f prime, of -2 is equal to 3 over -2 minus 1, which is equal to -1. Okay? So my point that I have here is -2, -1. And then from there I can use point slope form, and it might be helpful to review what point slope form is really doing. So I can say y minus a -1 or plus 1 is equal to the slope times x minus the x coordinate, or plus 2 in this case. This gives me y plus 1 equals -1/3 x minus 2/3. Bring it up here to finish. This gives me y equals -1/3 x, and subtracting 1 from both sides gives me -5/3. And so there you have it. We found the derivative of the function. We use the derivative function f prime of -2 to find the slope of the tangent point, of the tangent line rather, and then we use the point here, -2, -1, in order to find the equation of the line, of the tangent line.